Okay. So if you remember, right, the quadrilaterals that we've been talking about, a lot of them have like parallel parts to them. And so we can use the coordinate plane. If we have a quadrilateral in the coordinate plane, we kind of use slope in the coordinate plane to help us, identify what kind of quadrilateral we're dealing with. All right, so we're not going to worry about any of this stuff going on right down here. We're going to turn the page. Okay, and in fact, skip that next page. We're going to go to page 497. We're just going to jump right into basically how we're going to be using this. Okay, so we're going to use slopes to classify quadrilaterals by their sides. So you can use the slope criteria for parallel lines. The slope criteria is that if two lines are parallel, their slopes will be equal, to analyze figures in the coordinate plane. Okay, so we're going to show that each figure is the given type of quadrilateral. So this quadrilateral we got right here, we want to show that ABCD is a trapezoid. All right, so to show that a shape, or a quadrilateral, is a trapezoid, all right, Michael, what will it be sufficient to do? What does it mean for a shape to be a trapezoid, or for a quadrilateral to be a trapezoid?
They have to have at least one parallel side.
Beautiful, and you can put the at least in there too, exactly right. At least one pair of parallel sides. So it'll be sufficient here, Michael, for us to show that this shape has one pair of parallel sides. That's all we need to show. Okay, so what does it look like in the picture here, Michael, will be the two parallel sides?
AB and CD.
AB and CD, right. So is it necessary for us to find the slope of all four parts here?
No.
Yeah, no, there's four sides. We don't need to find the slope of all four sides. Just two of them is fine. And so we'll zoom in there on the AB and the DC parts. Let's do that. All right, so if we look here at AB and DC, all right, how can we find the slope of, let's find the slope of AB here first. So slope of AB, all right. Patrick, how can we, or not, sorry, not Patrick, I'll do it to Adam. Adam, how can we find the slope of that segment AB there?
Find the rise over 1.8 point B.
Okay, great, let's do that. So can you help me out with that? So we're going to go from A to B, we're going to rise how much? 2, and we're going up 2, so it's a positive 2. And then we're going to run how much? Right 3, so that means it's going to be positive 3 in the denominator, right? Great, okay, so slope of AB is 2 over 3. Okay. For those of you that like the slope formula, you also could have used, y2 minus y1 over x2 minus x1, right? And you can then use just the coordinates here. So, for example, B has a y-coordinate of 3, A has a y-coordinate of 1, so you could have done 3 minus 1 over the x-coordinate there of B is 2, minus the x-coordinate for A is negative 1. So 3 minus 1 is 2, 2 minus negative 1 is 3, and you still get the same thing, you see. So you can use slope formula, or you can count it. Okay, obviously the counting is easier here, so we can just do that. Okay, great. Very good. And then, Maria, what is the slope of CD? And let's count it here. So what's the rise? How much do I have to go up? 4? Let's see here. 1, 2, 3. Yep, looks good. 4 over how much? Well, we're going to run 6 to the right, so that means a positive 6, right? Okay, so there's our slope. And again, you can use slope formula. What's that? We can simplify the 4/6. Okay, what does that simplify to? 2/3. So there we go. Okay. So, Zishan, is this quadrilateral a trapezoid?
Mm-hmm.
Why?
They're both the same slope.
Okay, they're both the same slope, so therefore, AB and CD are what?
Parallel.
Parallel, exactly right. Okay, so, since, how do I want to say this? So let's see, AB is parallel to CD, so ABCD is a trapezoid. Okay. We do want to have that little kind of concluding statement there because it kind of brings everything together. Yes, all the work is there, and most of you guys, once you see the work, maybe you're like, okay, yes, that's done for it. Now I can analyze that. But we want to have that concluding statement there to kind of show that we know what we're doing. So just having the slopes is enough for you to maybe convince yourself. But you then need to make this statement for someone like me, so I can see that you know what you're talking about. So AB is parallel to CD, so ABCD is a trapezoid. Okay. Questions on any of that? That's pretty much it with that, okay? All right, let's look at letter B. All right. So, all right, so Evan, letter B says, show the PQR as a parallelogram. How can we do that? What makes a parallelogram a parallelogram?
They're parallel sides.
Two sets of parallel sides, okay, so that's one way to do it. Yep, so how can we determine if we have two sets of parallel sides here? What can we do?
So, you can see it's the two, intersect.
Okay, so if the, for example, so give me a set of possible parallel sides here. PS and QR. Okay, so how will we know if they're parallel here? What can we do to figure out if they're parallel? Yeah, let's do that. Okay, so slope of PS equals, and what would the slope there be, Evan? Over 2? Yep, over 2. So the rise is, or sorry, the run is 2, positive 2, because you're going right 2, I guess, right? And then what's the run, or what's the rise, sorry? Yeah, -4, right? Because if you're going from P to S, we're going down 4, so that's a rise of -4, and then run of positive 2 because you're going right 2. Good, okay? And then let's find the slope of QR. Okay. And what's that slope there, Evan?
That is 2, going over 2.
Okay, run is 2. 2 to the right or 2 to the left? To the right or to the left?
As a RQ.
Okay, that's fine. And then
That'd be
-4?
-4, yeah.
Yeah. So you can go from R to Q and calculate the slope that way. That's fine. That's fine. You can do it that way.
But don't you have to do SP?
Nope. It would still be the same thing. So let me show that real quick. So if we found the slope from R to Q, it's going to be a +4 rise and -2 run. So that would be 4 over -2. Okay? Are these two numbers different? Is -4 divided by 2 the same thing as 4 divided by -2?
Yeah.
Yeah, they are, right? So it doesn't matter where that negative is. Okay, it's just the fact that it's negative. Okay, great. So is PS parallel to QR?
Yes.
So is the shape a parallelogram?
Yes. Not yet.
Not yet, right? But we've only shown it's what so far?
Trapezoid.
Just a trapezoid. Very good, Evan. That's right. Okay, so what do we still have to do here, Evan?
Find PQ and SR.
Slope of PQ, slope of SR. All right, so let's do that. Slope PQ, slope SR. Okay, so I'll just count those for you. So let's see. PQ is what? -2 over 4?
Yes.
Yep. And then SR, same thing. -2 over 4. Aha, so it is a parallelogram, right? Exactly. Right? So again, what can we say here? How can we kind of justify this? What we are concluding kind of statement B? What do you say, Evan? Or do you want to let someone else give it a shot? All right, pass it off, right? Let's see here. Who haven't we heard from yet? All right, well, let's go to Patrick. Patrick, your number came up there. So what do you say, Patrick? What's our kind of concluding statement here? How can we then pull this information together in like a little sentence and say that now we know this thing's a parallelogram?
Well, because PS and QR have the same slopes, they're parallel, and because PQ and SR have the same slopes, they're also parallel.
Okay.
If there are two sets of parallel sides, it has to be a parallelogram.
Beautiful. Exactly right. Okay, so I'm gonna use some symbols here. I'm gonna use PS is parallel to QR. Okay, and PQ is parallel to SR. So opposite sides are parallel. And PQRS is a parallelogram. Okay. Is this the only way that we could show that this PQRS is a parallelogram just by using the slopes? Is that the only way we could do it? Yeah?
Can you
100?
find the distance of each line?
Okay, so you want to find the distance of each line. Okay, so what do you mean by that? The distance of, for example, what?
Like PQ.
Okay.
And like R.
So find the distance of PQ and what else?
So you have to find them for all of them.
Yeah, all four sides. And then what are we looking for if we find the distance for all four sides? So if PQ is the same thing as QR, and if that's the same as RS, and if that's the same as SP, then this is a parallelogram?
And it's a rhombus.
It would actually specifically be a rhombus. That's right, yeah. And in fact, I think this does end up being a rhombus, doesn't it? Because it's down to, I think it would be actually end up being a rhombus here, yeah. Okay, and so therefore, since it's a rhombus, it must also be a parallelogram. That's right, okay. If we're just trying to show it's a parallelogram, do we need to show that all four sides are congruent?
Just opposite.
Just opposite sides, right. So again, you can use the distance formula for this side and this side, use the distance formula for that side and that side, and that would also work. Yep, exactly right. Okay, so yeah. And that's about, I mean, there's actually one other way I could see us doing this, but it would like be a lot more work. So what's true about the diagonals in a parallelogram? They what? Bisect each other. So we could find the midpoint of a diagonal, which is I think like right there, and we could find the distance from the midpoint to R, the midpoint to P, the midpoint to S, the midpoint to Q. And if these two distances are the same, and if these two distances are the same, then that would also be a parallelogram. But yeah, that's a lot more work. I really feel like the slope is probably the fastest way to do it. But if distance formula would absolutely work there, for sure. For sure. Okay. So let's flip it over here, and why don't you go ahead and try 4 and 5, okay? Give 4 and 5 a shot. Okay, so give 4 and 5 a shot. Show that they're a parallelogram, show that they're a trapezoid. Okay. Okay. All right, so Hunter, what do you say here? What you come up with? Is JK element trapezoid?
Yeah.
Okay, and what'd you get for this? How did you figure that out?
JK and ML always have the same slope.
Okay, what is the slope of JK?
Negative 1/3.
-1/3. And how about the slope of? Well, I guess if you say it's the same, you're probably going to say the same thing. Let's say -1/3 as well, right? Okay, that's right. So, did you give like a little sentence there or anything like that?
I mean, like, they have the same slope, so they have to be, like, equal to each other.
Okay, so JK, yeah, ML are not, well, they're equal slopes, so that means they are parallel. There you go, that's right, okay. So, quadrilateral, I'm going to abbreviate that, quadrilateral JKLM is a trapezoid. Okay, great. Cool. All right, and, oh, Shannon is not here. Drew, number 5. Is it a parallelogram?
Yes.
Yeah, did you use the slope method here as well? All right, so let's see here. So, slope of AB, what'd you get?
6/4, and then I just simplified it to 3/2.
Okay, good idea there. And the slope of BC?
I got -2/1.
-2/1, okay, which simplifies to -2/1. Slope of AD?
-2/1.
Okay, and then slope of, oh, I missed something here, didn't I? CD?
Yes, 3/2.
3/2, okay. So very good. So AB and CD are parallel, BC and AD are parallel. So AB is parallel to CD, and AD is parallel to BC. So opposite sides are parallel, and quadrilateral ABCD is a parallelogram. Okay, great. Okay, question?
It was just kind of like a observation. Basically, the way they're wording the question, like, show that JK element's trapezoid, aren't they wording it like they already know it's trapezoid, but you're just kind of, they're telling you just to show how it's trapezoid?
Yep, we're verifying it. Tomorrow we're going to look more into, like, what is this shape? Based on what you see. And, like, I might just give you, like, 4 coordinates. You're going to plot them. Okay, you'll look at it, and you maybe, you know, I mean, because even if you just look at this, you look at that, and you say, probably a parallelogram, right? Or this is probably a trapezoid. But again, you'll then verify that using this stuff.
Yeah.
Or what I could give you is, like, I can give you 3 points, and then ask you to come up with, like, the 4th point that would then make the shape a square, a parallelogram, a trapezoid, whatever it might be. So that kind of deal. But we're starting out, yeah, more basic today, just so we make sure you got that down. In fact, you can kind of see that on the next page there, like what's coming up there. So we'll do that tomorrow. All right, so that's for this unit, okay? So if you want to hold off on this, hold this to the side real quick, or I guess you didn't tear it out, so we'll come back to that. We're going to look at the perpendicular section here real quick. So on page 509, if you want to turn to that, okay? we'll go through that, and then we'll get you started on your assignment. This is pretty much it, okay? So parallel lines, their slopes are equal. How are perpendicular slopes related? How are perpendicular lines, how are their slopes related? Yeah.
Isn't like it's opposite and flipped?
Yeah, opposite flipped, or opposite in the mathematical term reciprocal, right? So that's right, exactly right, okay? As a result, though, since it's opposite reciprocals, if you were to multiply those two numbers together, you would always end up with then -1. And so that's two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Now, do you have to figure it out using that method? No. You can just, do the opposite reciprocal thing. That's fine. But yeah. Okay. Again, perpendicular has shown up in a couple ways, right? So, for example, what quadrilaterals have perpendicular, would have like that perpendicular idea show up in them? So yeah.
Oh, rhombus.
Ah, rhombus. Now, where does perpendicular show up in a rhombus?
Like
The inner thingies that we draw. Diagonals. What about them?
they're perpendicular.
Yeah, diagonals in a rhombus are perpendicular. Very good. What other shapes have perpendicular relationships show up? Or what other quadrilaterals, I guess I'll say?
Rectangle.
Yeah, rectangle. The sides are perpendicular to each other. And what about what's one more? The square. That's right. Also perpendicular sides. That's right. Okay. So let's flip the page here on page 511. 511. Okay, we're just gonna we'll look at just this first one here, okay, and kind of, I think we should be good after we see that first one. Yeah. Okay. So we want to show that this quadrilateral is a rectangle. All right. So ideas here. What can we do to maybe show that this quadrilateral is a rectangle? What do you think? Anyone have any ideas here what we could do to figure out if this quadrilateral is in fact a rectangle? What makes a rectangle, for example? So what can we do here? How can we figure out if this quadrilateral is a rectangle? Zishan, you got an idea?
Two sets of parallel sides.
Okay, two sets of parallel sides. If we show that we have two sets of parallel sides, what does that then make this shape? Parallelogram. Okay, so we can make it a parallelogram. That's one thing we can do. And then what else could we maybe do then to show that it also, though, is going to be a rectangle?
One side's congruent, and the other side's congruent, and so all the sides aren't congruent. So
Okay, so that's true. But that's true for a parallelogram too, right? Opposite sides are congruent in a parallelogram, just like in a rectangle, and not all four sides are congruent to each other. So that would still be true for a parallelogram. So we need something that would guarantee that would also be a rectangle. So it's a right idea, but so how can we make it? How can we take it from parallelogram to rectangle? So you have the right idea. Well, maybe let's do what you said to do first. Let's find those slopes first. Let's make it a parallelogram first. All right. So let's get these slopes. So let's find the slope of AD there, Zishan. And what do you say the slope of AD is?
a half.
So careful. From A to D, what's the rise?
2/1.
Yeah. And -2/1, right? Yeah, because we go down 2 to get there. Okay, very good. Yep. And let's do the slope of DC. Okay, what's that slope going to be? That's a little bit harder to count, isn't it?
3/6.
3/6, which simplifies, doesn't it?
1/2.
1/2. Good. And then what's the slope of BC?
It's -2/1.
Good. And then what's the slope of AB?
It's also 3/6.
Also 3/6, which is 1/2. Very good. Okay, so we have that verified. Opposite sides are parallel, and then the other two pairs of opposite sides are also parallel. The slopes are equal, right? So again, any further thoughts on how you can maybe say, we can also say it's a rectangle then? Actually, we have all the information right there for us. If you're not sure, that's okay.
I'm not really sure.
Not sure? All right. You want to help him out there, Tanner?
AD and CD should be perpendicular
Okay, how do you know the AD and CD are going to be perpendicular here?
because they're opposites.
the slopes are opposite reciprocals, okay? And in fact, that's all it takes, is just one angle. Once we've shown this thing to be a parallelogram, right, all I need is to show that one of those angles is a right angle, and so, for example, Tanner, which angle did you just show to be a right angle? If you used AD and DC's slopes, which angle did you just show was a right angle? Yeah, angle D, because AD is this side of that angle, and DC is the other side there. Just knowing that, and that this is a parallelogram, right, opposite angles in a parallelogram are congruent, so that means B will also be a right angle, and consecutive angles in a parallelogram are supplementary, so if that's 90, that'll be 90, and then the opposite angle, opposite, that's 90 as well. So it makes it a rectangle then. Boom, we have it, okay? So all the work is right there, okay? So we can say something like this. AD is parallel to BC, and AB is parallel to DC, so ABCD is a parallelogram. Okay? And then further, we can say that AD is perpendicular. And yes, there's a symbol for perpendicular. There it is. It's like an upside down capital T. AD is perpendicular to DC. So ABCD is a rectangle. And that's sufficient. Okay, so two little sentences there. What other ways could we have used? Well, actually, any questions on this? Any questions on that? Again, just slopes again. Just slopes mostly. What other methods could we have used here, though, besides that, to determine that this shape is a rectangle?
You can make the diagonals and the stretch of the diagonals and that's the same.
Yeah, exactly right. So 100 is exactly right. In fact, that in this case might be faster, because then there's only two things you got to calculate. You got to calculate AC's length and DB's length, and if their diagonals are equal, that guarantees this is a quadrilateral without having to first show that it's a parallelogram. So yeah, that might be a faster way to do it. Okay, sure enough. Let's see here, and I think that's pretty much the only other method I could think of there. Yeah. Okay. So questions on any of that? So that's the basic idea. Okay. So that being said, I'm going to give you an assignment from this section, and then also something from the previous section too there. Okay. So here we go.